The goal of adding syntax objects to Mo was so that Mo programmers can write macros to extend the language. That is, a Mo programmer should be able to implement a delay macro so they can write delay 1 plus 2 and have it get expanded to a function that takes a dummy argument to add 1 to 2 on demand. Now, if we just write some Shplait code, we know how to write a delay function that takes a syntax object, matches it to a delay form, and produces a function form. And we can check that this delay function works as expected, that it changes delay 1 plus 2 to fun dummy 1, 2. But we want to write Mo code instead of Shplait code. So we get one step closer by just dropping the check form here. We can still call a delay function, and we should get the right result out. Now we can take this, and it's almost Mo code. We just have to change the percent signs, the dollar signs, to percent signs. And we are already using match with just a pattern and else. We can't call an error function, so we just return an identifier bad delay, which will trigger a free variable error later if you give it a bad delay form. So not ideal error reporting, but good enough for our purposes. This now is Mo code. It defines a delay m for delay macro function that takes a syntax object, but it still doesn't let us write a delay expression as part of our Mo program. This is just a quoted syntax object, and we'll get a syntax object back. So the key next step is to introduce let macro. That lets us bind the delay identifier in such a way that when we write unquoted in Mo, this delay form, it gets replaced by a function form instead. So that's where we're going. Let's look at one more little example though. Suppose we wanted to write a cond form. So a Mo programmer wants to add cond to their language. Now, one way to expand cond is to take any number of cases here, x equal 3 and x equal 4 and so on, and generate nested ifs. So each if will use a plus and a times of a minus in order to fit it into our if 0 that we have built in. Instead of dealing with any number of cond cases all at once though, a common strategy is just to unwrap one layer at a time. So we can also expand cond to a single if with a nested cond inside. And then this cond will take care of all the other cases, whereas if here takes care of just the first case. So this is going to rely on the fact that when we take a macro and expand it, the result of that is going to get expanded again if it has any uses of macros inside of it. So what we're doing here is all we have to do is match 3 pieces, the first part, the first result, and the rest of the cond, and organize it into these 3 pieces here. We also need to deal with the case that else is the only thing that we have left at the end though. So our macro need to recognize cond with else and then just expand to just that expression because there's nothing else to check or try. We can write that in Shplait as a function like this. So here the cond m function is going to take this cond pattern with just an else in it and return no, and it does that because that hits the first pattern here. Whereas if we get a cond with more things, it's going to hit the second pattern where we've got at least one name equal to some number with a then and then more stuff after that. Then we do one transformation on if like this. Okay, so we want to get this into Mo. We'll drop the check just like before. Now we've got a function. Now when we try to change this to Mo code by replacing the dollar signs with percent signs, we're closer, except there's this ... thing, and we did not implement patterns with repetitions like this. So in this case, we can't really implement the full generality of cond, although we could at least have 3 cases to match just else, just one case before else, and exactly 3 cases, and that turns out to be good enough for this example. So this shows how you want ... to do things in general, but we can still write useful macros at the Mo level. Again, this is a cond m function. We want to use let macro so that we can really write in the rest of our Mo program cond and have it do the if dispatch that's nested. So to get to Mo with macros, starting from Mo with syntax objects, we need to build one more thing into our parser, and that is going to be a let macro form, where we have let macro, a symbol, an expression that we expect to produce a function, and then the body of the let macro, where that body is, its result is the result of the overall let form.